Okay. Shall we start, sir?
Yes, sir.
Good afternoon, everyone. I'm here to have an introduction for today's ATAL FDP session, which is day 6, the first session on 10th January 2026. Today we have a resource person, Mr. Vikas Chandrasekhar Shreshthi, sir. Uh, we are privileged to have with us today an accomplished professional from automotive software domain with over 15 years of experience in embedded systems and more than decades of expertise in automotive software development. Currently associated with Electrobit Germany, a reputed German-based organization, Mr. Vikas sir is actively involved in developing advanced software solutions for modern software-defined vehicles. Through a rich professional journey, he has witnessed the remarkable transformation of automobiles from primarily mechanical machines into intelligent software-driven systems. Especially with the rapid rise of electric vehicles, this evolution has inspired a deep interest in the application of artificial intelligence in electric vehicles, particularly in enhancing battery performance, safety, energy efficiency, and the overall driving experience. A strong collaboration learning, he firmly believes the knowledge becomes more meaningful when shared. This belief is reflected in his active participation in the organization of peer learning sessions where ideas are exchanged openly and complex concepts are explained in a simple, practical, and engaging manner. It is an honor to welcome such an experienced industrial professional Mr. Vikas sir to this ATAL FDP session. We look forward to gain valuable insights from his expertise and real-world experiences. Once again, I welcome Mr. Vikas Chandrasekhar Srishti sir for our ATAL FDP session.
Uh,
Now I request
for
Vikas sir to start with his session.
and we'll share screen and maybe I'll start the session which we are here to maybe discuss and understand about. Yeah, so maybe I think introduction is already done. I will not spend much time again on discussing on anything those topics. I decided to speak on this forum on this particular topic because I think this is interesting a topic, and also it has solved many problems which traditional vehicles were facing. EV has solved it, and then whatever problems EV was facing, artificial intelligence has helped to solve it and made it better for day-to-day life. So when we are starting and discussing about artificial intelligence in AV, I want to start journey from actual EV and then slowly get into artificial intelligence and then maybe explain or discuss and tell about what all places artificial intelligence has been used in EV. Probably we can touch on certain areas where what all inputs AI takes from EV to perform certain actions or to solve certain problems. So this would be the contents which we are going to look at it today. So from why EV were brought into a picture, then challenges with EV, then different types of EVs, batteries used in EV. Then we slowly move into AI side. What is AI? Basic information, maybe in one slider. Then why really AI is required in EV? So what was the drawbacks only EV was having, which it is trying to solve, and then where all EV has been utilized. So these are some areas where AI has been uh, uh, helped EV to become better and solve its problems. And what is the future of EV, and also career opportunities regarding to this particular topic. Uh, yeah, so Before going into EV discussion, let's stop and understand why EV came into picture. So basically, traditional vehicles, which were engine-based vehicles, they were using engines to go from point A to point B, and which was basically by by using a fossil fuels or by burning of fossil fuels. They were generating the energy and moving from point A to B. But that was also having some problems it on its own. Basically, traditional vehicles, as mentioned here, they were powerful, but they were not sustainable. What it means was, apart from generating energy, they were also releasing and making the environment polluted by releasing a CO2 when it burns the fossil fuels. So the important and main factor about traditional vehicles is environment pollution, and then also that its dependency with fossil fuels, be it petrol, diesel. So these fossil fuel dependency with them is always risky, because fossil fuels are, as everyone knows, they are limited resource, and dependency with them is always a harm, because as per demand and supply changes, the price also changes, and it costs heavily for the end user actually. Apart from that, it is very it's not very energy efficient. They use a lot of fuel, but actually utilizes very less. Noise and vibration problems were there, so whenever this engine works, it creates a lot of noise. So noise pollution is another problem. And at the end, basically, we are seeing that globally there are pollution norms which are getting reflected and getting stricter and stricter day by day, and that is another challenge which these traditional vehicles are facing. So it is really hard to meet these emission norms, and to meet these emission norms, again the vehicles have to spend more and more resources and money in that, and at the end the vehicles will become costlier. So how EV is tackling these problems? So basically, what EV basically touches all these points, and also is helping here. So EV for environmental reasons, as we all know, EV does not produce any emission from a tailpipe. So it is a zero emission from tailpipe. Then it supports cleaner cities and better air quality. So wherever EVs are running, air quality is not degraded as per the traditional vehicles. Also, it is a major impact of EV is it aligns with the global climate goals, where everyone wants to make sure that their countries are zero emission, emitting a CO2. So basically, EVs are helping everyone to reduce the pollution wherever we live and breathe clean air, I would say. Then uh, EVs are also energy sustainable, and also they are not dependent on fossil. So it can also be charged by using solar, wind, or renewable electrical sources, which removes the dependency of fossil fuels. Of course that is another biggest advantage here, which we have. And it is a technology driven. EVs are technology driven. They are more efficient. Electric motors are 90% more efficient than engines, which are very less efficient, up to 40%. And even the along with the time frame, the EVs and batteries technologies are getting cheaper and also better with respect to their storage and range coverage, I would say. So in that way, in 2014, every battery size of EV used to have only capacity of 24 kWh, and now it is around 60 kWh. So there is a lot of research and R&D is happening in this section as well. So with this approach, I think it will be very highly reliable transport mechanism in future, or I would say it's already a highly reliable mechanism right now. Also, it has a very good user experience in terms of uh, lower running cost, and also the ride quality is smooth and noise free. Uh, and why EV also, the major and important part is what we can see is the projected growth of EV. So that is around $823 billion by 2030. So which means that EV is only here to grow further in the upward direction. Now, having said that, uh, every uh, uh, every evolution or every new discovery brings its own challenges. So the EV has also its own challenges. The challenges with respect to battery is very important part of EV, and of course that itself brings a challenge as well. So as we know, we all are using handheld devices,
Hello,
mobiles.
hello,
Hello.
Vikas sir.
Yes.
Sir,
Is
can you
there?
please can you shift to slide mode, sir?
uh, I didn't get you. Is this not visible?
PPT is visible, sir, but not in slideshow mode, sir.
Okay, 1 minute. I will just share again. I'm not sure it's a problem. Uh, can you see my screen now? And which slide do you see? Let me know. I'll go into slideshow mode. Hello, Mazhar.
Yes, sir. Still
Uh,
not, sir. Screen is not visible.
screen is not visible. Just strange. I'm connected. Uh, is it still the problem, or do you want me to rejoin? Maybe I'm not sure. Was it visible at the beginning?
Yes, sir. At the beginning, it is visible.
Now you're okay. Let me rejoin, or I'll rejoin. I'm not sure what's the problem. I'll also shift the room so that I think the network connectivity would be better. 1 minute. Hello.
Yes, sir.
Yes. Let me know if you can now see my screen.
Yes, sir. Screen is
Okay.
visible, sir.
Okay. I will go into slideshow mode. Let me know which slide you are seeing now. Can you see the slides in presentation mode? Hello.
Screen is gone, sir, again.
I
Can you please reshare,
see.
sir?
No, I'm not able to share here. It says that only organizer and presenter can share.
Okay. Vaibhav Magdum, sir? Magdum, sir?
Just a minute, sir. I have already allowed you as a presenter. Let me check.
I just now rejoined, so maybe you can recheck.
You can check now, sir.
Yes, I can see now that option. Yes. Yeah, I am sharing entire screen. Let me know once you can see my screen. And
Yes, sir. Now
which
the
slide?
slide is visible. Challenges with EV.
It's in presentation mode, correct?
Right, sir. Right, sir.
Okay,
You can
so
continue.
now we are at the right place. Yes. Uh, so let me minimize this. Yeah. So I think, yeah, I was discussing about, yeah, with every new evolution, we also get a different set of challenges. So with EV, we have challenges on uh, certain places. So first is a battery related challenge. So battery degradation happens over time for any battery operated system in that case. So even if we are talking about mobile devices, handheld devices, their battery degradation happens over time. So at the time when you purchase a mobile, it works perfectly fine for the duration given, and later on it degrades significantly. Number of hours usage get degraded because battery degradation has happened. There are several reasons about it, and how AI helps here, that also we can check. Performance drops, also battery performance drops in extreme temperature, whether it is severely cold or whether it is severely hot temperature, the battery performance differs in these kind of cases. So, and we have very limited driving range compared to fuel car. So that's another challenge which EV is dealing with right now. There are charging infrastructure challenges, which are like very well-known challenge is very limited charging stations availability in particular areas, cause a biggest risk, like running out of charging when we are driving. Then long charging time compared to refueling. So this is another place where usually comparison happens. Refueling happens very quickly, whereas charging takes time, and of course that impacts decision making of a end user. Fast chargers are also expensive. That's another problem. Fast chargers are there, but they are super expensive. EVs are mainly based on softwares, and that is also a good part, but also that's a challenge because whenever there's a system failure, it affects multiple components. Whereas traditional vehicles, if there is a failure, a particular component fails, at least other part of vehicle still runs. But of course, in all these challenges, R&D is happening to resolve these challenges. The next is range anxiety. So as we saw here, limited driving range. It's the same thing. Range anxiety for user when they are when they can run out of a charge, they always have fear of that. And the EV range prediction can differ 20 to 40% based on the driving style, traffic, AC usage, and road condition. So basically, whatever range we are getting or prediction we are getting, that's based on a standard algorithm. AI helps here to improve that standard algorithm by taking into consideration various different factors, and tries to give more and more optimized and correct solution than a standardized solution. Uh, then thermal management and safety challenge. So battery overheating can cause, maybe we have seen a lot of cases as well, where due to battery overheat, the explosion has happened or car movement is not has happening. So in such cases, basically what we need to do is we need to make a thermal management. We have to avoid the battery overheating, or even if it is very cold environment, we have to make sure that a battery temperature is optimum to work battery properly. So the thermal management is the biggest challenge in EV. Cost and affordability, of course, upfront cost is way high than the traditional vehicles. So that's another problem and challenge. Sorry, battery replacement cost is also high with the EV. So these are the challenges which EV is facing. Before jumping into I will just touch up upon uh, different types of EV in short. So there are mainly four types: battery operated vehicles, which we are seeing day to day life. They are vehicles which only runs on a battery and needs to be charged on the by plugging into the socket. Hybrid vehicles, on the other way around, they have brought in by OEMs to remove the fear of range anxiety from the users. So when they want to travel for longer distance, they can just switch from battery battery to fossil fuel, and they can travel to the longer distance. Maybe a intracity travel can be done by using a fossil fuel, and when you're traveling for a shorter duration, battery can be used. So this will reduce emission, also provides user possibility of switching the engine types. There are two different types here. I don't want to go in detail, but basically what it does is, in one method, the battery setup is very heavy. Apart from fossil fuel, battery setup is very heavy. We need to plug in the battery to the power resource and charge it in according to use it. And we can only switch, then only we can switch in between these two. And in the other one, battery setup gets charged internally by using this fossil fuels speed and brake by braking technology. But here the con is battery setup is very small, so whatever battery usage is very limited. Third type is FCEV, where fuel used is H2 fuel, hydrogen, which basically generates electricity and charges the batteries. This does not generate any emission, whereas the con for this is the setup for this is very high, very huge, and it makes end product very big. So cars created from these are very big, and the most of the space is taken by this particular setup. And the last one is extended range EV, which are same as this battery EV. They only have an extra engine which acts as a generator to charge batteries on the go. So the range which EVs are providing gets almost doubled, or maybe 1.5 multiplies by 1.5. Okay, these are the some standard sets of types of EVs. Then we will take a look at a very high level overview about types of batteries. There are several types of batteries which are used in EV. Just a moment. Yeah. So, and also there is a lot of research happening on this particular field about batteries and EV, which battery to be used in which particular uh, working environment. So based on all the parameters, like where the car is going to be deployed, what kind of area it is, what kind of temperature will be, what kind of terrain it will be, the batteries will be selected. Also, there are certain battery properties. By evaluating those properties, a particular batteries are selected for particular EV by OEMs. So battery properties such as capacity, then energy density, lifespan, how long a battery can be used, operating temperature, so and maybe how fast it can be charged. So based on all this information, best fit model will be selected. So right now what we are seeing, most of the batteries used in EVs are Li-ion or Li-polymer batteries, which have been seen in the day-to-day life or in India as well. So we can see that these two are used mostly. They have their own. Again, every battery set has their own pros and cons. Of course, the experts sitting inside the companies will take care of these particular topics. Now, let's go to next point. So now, before seeing how AI is helping to solve the challenges of EV, we will understand in just about AI. What is AI? So basically, AI is these days you must be hearing this particular term very often. And we have also seen that AI has reached to all most of the places. AI is there in television, AI is there in handheld devices, even the social media which we are engaging with. That also using AI for making sure that the person who is viewing the content gets engaged more and more. How does it do that? So it's basically takes the data, learns from it, recognizes the patterns, creates the patterns, and then makes the decision. So if certain person is engaging for certain content, or if particular based on the particular data, AI model understands that the interest of this particular entity lies towards this, then it will start giving more and more related information to a particular person. So this is what AI does actually. uh, there are there are different types of AI, basically machine learning, natural language processing, computer vision, deep learning, and there are these again three different fields are there. We are not going in deep of this. In short, deep learning is the very a starting stage of AI, where it uses different mathematical models to understand the data and predict the next output based on the next input of what it can be. And After this comes is machine learning. Machine learning is again a subset of AI. Machine learning has a different types of machine learning: supervised, unsupervised, reinforcement. And again, these are used and decided by AI and ML experts, which learning algorithm needs to be used where and based on what data. So these decisions will be taken care. So machine learning is used in many places in the day-to-day life. Apart from that, we have this natural language processing (NPL), that is text classification, summarization, and generation. So to give an example of these AI techniques, we have a chat GPT, or you say any different kind of a chatbot. These all are built on this particular AI model. Basically, we give a query, and then it generates a text by by referring to its input data, and then basically it gives us a text. Also, it summarizes the text. If we give a very big document and ask it a one-page summary, it will do that by using this model. The third is computer vision. This is nothing but mostly image related data identification and classification, and it's mainly used for you say autonomous driving. So when car is moving and it wants to understand what colors, whether there is a signal on the road, it is red, green, or orange. So first it will get the picture of it. It will understand, it will classify the image, it is a signal, and then it will take a decision based on that. If it's red, it will stop the car. If it is green, it will move ahead. Object detection, same way, it is used to detect an object on the road. If there is a car in front of a car, then it detects by using this algorithm and understands that there is a car, and reduces the speed automatically or takes the specific action accordingly. Then yeah, we have these other different parameters or AI techniques which have been used, and they are growing these days. There is a Gen AI, there is conventional AI. We are not going in details of those now. Let's come to a point where how or why AI is used in EV, or how AI is solving problems in EV. So in EV, we saw that there are many problems like battery management, energy management, energy efficiency. These all can be solved by AI because EV generates a data, and as we saw, what AI does is takes the data, recognizes the patterns, and makes the decision. So basically, the data generated by different sensors is read by AI model, and then it is utilizing it, and then it is making a decision for suppose for charging way of charging batteries. So there's a standard way of charging a battery, like we connect the connector, and it charges with a particular particular ampere. Now that is not possible every time, or if we use that, there is a possibility that batteries performance get degraded because they are heated already, and we don't want to do that. So AI keeps track of all such data and creates its own algorithm based on that, and applies to it. Battery performance is unpredictable. So basically, this is again for predicting the range. AI can be used by utilizing a different factors, understanding the weather condition and understanding the terrain. The AI will help us to predict the battery performance as well as the distance which we are going to cover. Safety and efficiency manner. So there are various safety cases which can be done by using AI. A few of them we already discussed in the previous slide, like there is object in between the road, and we don't know, or the car gets slowed down automatically if driver's distraction is there. Then we have software defined vehicle behavior. Software defined defines a vehicle behavior is nothing but in the traditional vehicles, most of the vehicles were only hardware based. Software based components were very little. Now with EV, most of the stuff is defined and controlled by a software. So performance of a motor or a battery consumption output. So basically, these all things can be controlled and monitored and configured by using a software remotely. Uh, and how that is possible? That is again possible by connected cars, basically, or connectivity of a car with different servers and different components. So based on that particular data, AI can define or control a specific uh, configuration of a motor, or and maybe give a more performance or less performance. So basically, software will define the how vehicle is going to behave, whether it is going to run in a sport mode or whether it is going to run in economical mode, is defined by this. So to give an example, in our phone, it's like when our phone's battery is draining and it's almost last 15%, 10%, phone automatically switches to a power saving mode, where it doesn't allow you to maybe connect Bluetooth or connect Wi-Fi. Mostly unnecessary operations it doesn't allow, and it only allows you to make a very important things like making a call or maybe using a data connection. So the same way here, AI or software can define the vehicle's performance based on the situation. And to come to situation again, it takes the input of various parameters. So this one slide I have added just for reference. This slide is there. It tells that how each of the challenge is handled by or solved by AI, and by using which technique. So as we saw, AI has many techniques and many different algorithms. Which of that technique is used to solve which problem? So if you see here, range prediction is done by using machine learning, and what application it has. So basically, it will give us a real-time estimation and what benefit it gives. So that I think, yeah, this can be referred because I'm going to cover every topic in short in the next slide. Yeah. So AI in safety and security. Um, I heard a noise. Is there any question or is there any input? Okay, I assume no. Let me go back. So we will start. We will see how AI is helpful in safety and security. I have just taken one emergency assist use case. I will show the video. Maybe let me know if you can hear the sound. It's not that. So basically, in this particular car, the AI has been used to detect the driver's drowsiness when particular driver goes into sleep while when car is ongoing. It detects the drowsiness and performs certain actions. So basically, detection of drowsiness is done by using cameras. Whenever it detects that driver has closed the eyes and it's basically sleeping mode, then it understands it and it starts taking an action which has been defined by a particular software developer company. So let's see this example. So here it has already detected the driver is fall asleep, and it has enabled the emergency assist to stop the vehicle. But before that, it has also tried to wake the driver by shaking the seat very strongly. Also, it vibrates the steering. If driver's hands are on steering wheel, then he can also wake up by that, and also makes a very loud sound. Still, if user doesn't wake up, it starts it will start taking vehicle onto the roadside and dials emergency call. I'll just finish this. Yes, so uh, if you have seen this, yeah, so basically it has made finally an emergency call to nearby stations or nearby police or whatever emergency contact number a user has configured there. This way, it helps and makes sure that a person or user who is driving is always safe. Apart from that, for cybersecurity, how AI is helpful is whenever there is a threat detected or intrusion detected in a software from external world, it will understand the anomaly behavior or a different behavior. Basically, again, it's always collecting the data and understanding and analyzing and creating the pattern. So it understands that there is a different pattern, and based on that, it understands there is a cyber security threat, and it will basically provide a protection from that. So protection as such, maybe it will directly switch off its turn itself off from the internet connectivity or external world connectivity, so that the external threat which has been or intrusion which has been entered into the system gets blocked. So this is cybersecurity part. We saw autonomous driving, and collision avoidance is nothing but if there is any vehicle in front of the vehicle, there is a camera which is situated on top of the vehicle or inside this cabin here, which collects the image and creates a 3D map of that by using those images. That is called LiDAR technology, and by that and on that it applies AI algorithms and finds out the object is there in front of or not. If it is there, how long it is, and based on all this information, it takes the action like whether to stop a car or reduce the speed. So this is about safety and security, and of course, this particular topic is not with respect to EV. It can also be used and applied in the other vehicles. With respect to EV, let me go to the next slide. Yeah. How AI is used in thermal management. So basically, this is specifically with EV. So thermal management is nothing but batteries for EV must operate within a safe temperature range. If they are overheated, it can cause the uh, thermal runaway. To prevent that thermal runaway, what AI does is it always monitors the temperature on this, and based on this temperature, it basically takes action or whether to turn on the cooling system or turn off the cooling system, or if the vehicle is residing in very cold area, then there might be a heating system to make sure that battery remains in the proper normal working condition. uh, yeah, apart from that, it also monitors the voltage and make sure that charging is done at the optimal range and not the high or low, or basically it does not apply a standard one standard formula. So before AI, the problem was it is not like the thermal management system was not there. The thermal management system was there, but it was rigid, and it was having a standard formula. So until and unless temperature doesn't reach to certain level, it will not take an action. So here AI is taking care of getting this data, and it toggles, or it tweaks the algorithm according to the needs of specific vehicle, based on the area where it is, or based on the condition, driving condition, or based on the driver's driving style. This overheating can cause a performance loss, and it's also a safety risk. So by using this AI, what happens is we can improve this performance, and also safety risk can be mitigated. So this is about AI in thermal management. About AI in battery management, I shortly touched upon the point in the previous slide also, but let's go here. So charging optimization is done in battery management. Charging optimization is nothing but these days, if we can see, we have smartphones. When we connect the smartphone to power source, it gets 50% charged in the 10 minutes, and after that it does a slow charging. So basically for that also they have been using something similar. So the user wants immediate charging, so that has been provided for certain battery cells, and after that remaining battery cells are charged slowly. And this is also done in a smart way to make sure that all the batteries are charged, fast charge and then slow charge, so that the impact of fast charge doesn't deteriorate the battery cycle or battery cells. Apart from that, charging speed also depends on a battery condition. Now this information is not, or this particular information is neither covered or controlled in the previous legacy battery management system, because there was no chance we could read the battery condition and change the charging speed. Now with the help of AI, it reads the battery condition, also, and based on this SOC and SOH, it changes the charging speed. Now AI will adjust this battery charging speed dynamically, and avoid the battery management failures. So here small example explains that. So battery management takes these three inputs: battery performance, battery usage, and SOH and SOC. This is a real-time sensor data which has been read and used by AI, and to improvise the battery lifespan and charging efficiency. Yeah, so let's go to the next slide. AI for range prediction. So to predict the battery range, a standard algorithm doesn't take care the inputs, or doesn't consider the driving style of a user or a traffic on that particular point A to B, wherever we are trying to drive, traffic situations, or AC usage, because AC usage might change. Excuse me, there is a noise. Can you please check? Yeah, yeah, thank you. So on the hot day, it's possible that AC usage is more, and driving range or range prediction is different, and on the cooler day, the range is different and it will be easy. Also, a road slope or environment where we are driving also changes the driving range prediction. This is now considered and used by AI to predict the range more accurately. The algorithms have been used to understand the driver behavior, and then apart from that, it also reads the traffic situation, AC usage, by reading the temperature situations on that particular area, be it cool or be it warm, based on that AC usage or heater usage, and the road slope. And based on that, it predicts the range, and basically that will give us a safety and reliability about EV. So that is helping EV to become more reliable and more safe. Now, yes. Predictive maintenance. And predictive maintenance, as its name says, AI helps by monitoring all the components, sensors, data from that, and understands that if maintenance is required for particular section of EV at certain time. Again, this helps to improve the reliability and safety of EV, and also this is not standardized now. This is again a different algorithm for every vehicle based on driving style, terrain where we have driven the car. Also, if AC usage is more, it will understand that. In the previous standard algorithms, there is no way we can understand whether the component has been utilized or not utilized, and it really needs to be replaced or not. With the help of AI and with the help of data collection, this is possible because we get all the real-time data. We understand route navigation planning, and then we can also suggest the maintenance to user. This is also helpful when we are going for suppose uh, we are planning for a drive, and there is possibility of maintenance. Then we can immediately suggest the possibility because it already understand by finding out the range that person is trying to go to certain location, and to that location this particular component may not work until the maintenance has been triggered. So this helps us to uh, have a safe journey. It is reliable. Also, uh, it saves the cost, unpredicted cost, I would say. It improves the route efficiency and range accuracy by helping all by taking input of all this parameter. AI helps us to get to this particular stage. Yeah, so vehicle to everything, V2X. So this is, if you see this image, it will explain in short what it means. So this particular car is connected to a signal as well as this particular vehicle here, also the charging station here. So in short, this particular vehicle is connected to everything around which is possible, and by this it actually able to communicate with the signal to understand what is the situation or what is the traffic load, and also when it communicates to charging infrastructure, it understands whether it is empty, whether it is free, what kind of a possibilities, what kind of cars this particular infrastructure can charge, if it can charge this particular vehicle or not, and based on that it can again predict and tell you whether charging is needed and it should be done here or not. So for that purpose, this particular V2X is very important. Apart from that, the V2X is also important for taking the latest updates. In software world, it's always important to have a safety, and safety always comes with the uh, with the new security patches. Whenever there is a new threat detected, there is always an update, software update rolled out by the companies, organizations, and such software updates can be only taken by car if it is V2X enabled. Otherwise, it has to go to the center, and from the center, it needs to upgrade itself. Then only it will have the recent or latest feature which is disabling a threat. Now V2X is giving all this functionality, and it improves a user experience by basically user doesn't need to travel anywhere to update, or it gets all the information on his fingertips. So this is also this is energy saving, less cost, and connectivity enhancement features have been provided when we are talking about V2X. Yeah, AI in smart charging. So now this image is almost same, but we are talking about smart charging. What is smart charging? In the countries outside or even in India, the charging is to charge a vehicle when it reaches to a charging center. It doesn't charge statically. It charges dynamically based on the uh, demand. If there is a high demand or at that particular time and vehicle reaches to the charging station, the first disadvantage is vehicle has to wait. Second disadvantage is vehicle needs to pay an additional amount than it pays at regular time, or on the other time, like when most of the cars are not utilizing it, so odd hours the cost will be less. So the AI or smart charging concept is nothing but a V2X which communicate with multiple vehicle infrastructure around us and always understands what is the optimal time to charge our EV. And based on these analysis data, it it informs to the user that this is the right and perfect time to go and charge. If you are if the user is charging at this particular time frame, it saves the energy because the particular station is utilizing not utilizing the traditional way of creating energy. Instead it is utilizing natural way, and it will also cost less because this is an odd hour. So with that information, user experience is enhancing here, and that's nothing but smart charging. Also, it helps. Again, this provides a notification to user when he is traveling. He is about to reach to certain location, but there is no charging station in between. The information is known to car, so car can suggest it's better to charge in upcoming 50 meters or 100 meters, because there is no charging station after that, and we see that terrain is also difficult and we have very less energy or battery stored. So it's always good now to charge or not. And yeah, so that is a smart charging. Let's go to AI in ADAS. ADAS is Advanced Driver Assistance System. It basically helps driver to drive a car across a difficult situation, or it mainly helps the driver to drive by various. There are multiple features in this ADAS. I have taken few of them, like lane keep assistance, or collision avoidance, adaptive cruise control. So to use this all features, AI helps basically to collision avoidance, of course, as we discussed in the AI slide. It takes the image of the front car and decides how long it is distance, and based on that, it automatically takes an action to reduce the car speed. Adaptive cruise control is when driver is driving car at certain speed, and if vehicle in front reduces the speed, EV which is running adaptive cruise control automatically uh, changes the speed without driver intervention. Lane keep assistance is, yeah, we are driving from one lane and we don't want to go into other lane, so it always makes sure that car stays in that particular lane. If it is going out, then it either triggers a vehicle control, brings back into the same lane, or notifies the driver by some action. It again depends on OEM or car vendor, how do they implement this. uh, Remote vehicle diagnostics is another feature where we can remotely uh, see what all components are working in our car, or diagnostics is required for our cars certain components. So this all diagnostics can be done remotely. This feature can also be seen in the F1 race. Basically, when driver is driving the car, there is a person who can see cars internals and understand the mechanics of it. So the similar functionality is already been uh, used or utilized with respect to EV. And of course, remote software updates are only possible with respect to EV and connected car. This all provides us comfort, end user experience, improves the comfort, safety. It enhances the driver experience on the go, and also provides a control to AI. Uh, uh, Also, it provides a safety because there is also possibility that, as we saw one video, that the driver drowsiness can be detected and action can be taken based on the driver's drowsiness. Yeah, so this is a small example of how it has been done. I would not go in detail. I would just maybe explain a few things here. This is the LiDAR sensor which we were see, which we can see here, and that is responsible for uh, taking the image of the area which is in front of a car and creating a 3D map out of it. And then that map is provided to an engine or basically AI model, which detects the map and then sees possible things like a signboard or a moving car or a moving person, walking person, or a signal, any of that. And based on that particular thing, AI model informs to a control unit particular action to be taken to either reduce the speed or stop the car, or maybe inform a driver that there has been signal and he needs to be stopped. Uh, yes, so this is one way, one interaction. Apart from that, there are these cameras which helps. They are always focused on the face. If you use uh, AI read that the face expression, whatever, that it understands the driver. Uh, then so face by using command, in the equipment, speaker, mouse. So this improves in vehicle experience. So what we use now is and EV being a vehicle over problem, then just which EV and um, how helping most of the uh, to get the possible outcome, be charging uh, instead procedure, implementing a protocol, uh, cooling down thermal system for bad heating or experience. That see we are the last EV future. What is the future? What are that EV? Mainly we are and uh, this particular uh, uh, search search on battery to make sure range of extend uh, uh, it also because range is than uh, remain fast because there is an improve uh, algorithm improved improve time infrastructure improve, always depend uh, environment is also helps that uh, AI how how about video with charge. So station AI and uh, of charging station needs for it. Certain areas there are more required uh, uh, is yeah they require
Hello,
fulfilled.
hello, sir. Sorry. Hello, sir. Hello, sir. There's a
Hello.
disturbance in voice. Please check, sir. There's a disturbance in voice, sir. Please. Please check the network, please.
Uh, I think now from long time I have not place. Hello?
Yes, sir.
Sir, disturbance is there, sir.
Hello? Me? Hello?
Yes, sir.
Can hear me, right?
Yes, yes, sir. It is clear now.
Okay. So, actually, vehicle or it's acting charging and they request with their area is charging and create a tool for or uh, agency create an station or more additional in certain area. AI also uh, seen that e not durable, their battery not used long and or right now we things and we distributed more a little bit wireless used use a power we will charge with instant research and more design is not information is required so that it come strongly renewable needs to be charging ways used to charge the vehicle, which will again generating more and more as these are basic to reduce the be something like gets new and getting tired and it satisfies can use further improvements aspect. Are few picks or features for uh, path for
Sir, your voice is breaking.
happening for everyone. I'm not sure. There is no net lag from my list. Okay. Masar, can you please confirm that my voice is clear or It's still the problem.
Yes, sir. It is now clear, sir.
Yeah. So different career paths which can be chosen by candidates would be for embedded engineer, AI/ML engineer, ADAS engineer, data engineer. In ADAS, there is always a communication between ECU and AI/ML component, or sensors, cameras, and AI/ML component. So this is one of the area where it can be focused. AI/ML engineer basically works on the creating and generating a model which gives or predicts the perfect more and more uh, valid results than a standard protocol. Embedded engineers are mainly utilized or responsible for bringing up the entire system, uh, which communicates with the different cars, different vehicle station. Yeah. And data engineer's job is mainly towards cleaning up the data, gathering different data from the different sensors, different parts, and making it meaningful, creating or bringing it into a meaningful manner so that AI/ML engineer can use it to predict a more and more uh, improved or accurate output. So for example, suppose a predictive algorithm which we are using right now predicts 80% accuracy information. Now AI/ML engineer can come up with a new algorithm which predicts the output 85 or 90% accurate, and that way the improvement keeps on going. And if the car has OTA support or over there update support, these new updates which are happening in AI/ML protocol or um, algorithm gets uploaded into the vehicle. Uh, yeah, I just want to make a note here that these are on few of the career paths which I am only aware. I have written here. There may be more than that which are with respect to battery or motor technology, R&D, or maybe bringing up or controlling motor and battery by help of input from AI/ML uh, output, AI/ML models prediction. So these career paths, which I am not aware, but yeah, of course, this should be there. Only thing is, yes, one needs to find out. Apart from that, yeah, these are the references which have been used to bring up these contents to you, all the interested candidates. Uh, and I think, yeah, this is the right time to ask a question if you have any. Please let me know if you have any questions.
Magdum sir.
Yes, sir. Yes, the participants are allowed to unmute their mic and can ask the queries any, if any. If there are any queries, the participants can unmute their mics and ask the queries.
Hello, sir.
Hello. Yes.
Please give us the names of some models used in different cases, sir.
Yes. So I have one slide here which talks about the models. Um, it can be referred, or I will just go back. Yeah. So these are models which are used: fuzzy logic model, predictive control algorithm. CNN is a conventional neural network model, uh, and this NLP is in use here for in-vehicle experience, and for anomaly detection, machine learning has been used.
Sir, these are generic ones, sir. Actual names of the models, algorithm names, sir.
Uh, you are asking about mathematical model, correct?
Yes, correct, sir.
Yeah, so these models, when we are using machine learning, it internally uses these models, and these models, mathematical models, are only used in deep learning. They are not used in machine learning. Machine learning is completely based on supervised, unsupervised, or neural network based, which is reinforcement learning. And in this particular slide, if you see it, it is also using a neural network, and for machine learning. Uh, we have used for a range prediction one particular model that was I don't remember a name as of now, but I think yeah, we have also used a conventional neural network only. We tried CNN and then decision tree, and based on that, I think yeah, we had to take a call which one is better. But of course, there was a different team which was taking care of this particular topic.
Mm.
Yeah.
Okay, sir. Thank you.
That in future, is there will be any standards will come for this?
Uh, Standard for this,
Specific
can you be
standards
specific?
for this, uh, particularly regarding software, some standards they will come, or it has to be standardized.
Yes, there are certain standards right now for functional safety. We have standard of ISO 272753, which basically, okay, I forgot the number, but there is a function. There is a safety standard for cars, uh, where you have to basically decide the safety level of each car. So when you implement and bring AI in the car, uh, uh, it has to be specific to SLD, SLC, SLB, and SLA. So SLA is the most difficult and most critical one, where AI can take the decisions in the scenarios of life-threatening scenarios. So those decisions matters the most. So when a company has to launch a car which is SLB right now, that is also very difficult. So based on a lot of parameters, they have to first understand, and then they have to find out the particular use case which meets for ASIL B standard, and then they have to train the model for that, and then basically they perform a test, and then they launch it. So ASIL B standard is already there. ASIL standards are already there for uh, safety. Cybersecurity standard is also there, but I'm not exactly aware of what is the standard name. But there are certain protocols and rules and regulations which we need to follow for cybersecurity as well. So a team there is a team which goes through standard and checks whether any component which is running inside a AI module or automotive domain car is not uh, providing any vulnerability to end user, or it is not leaving any loophole, like uh, any external person if enters into the system, they should not be able to take over entire system. So they make sure that DAC has been implemented, MAC policies has been implemented, security policies has been implemented, so that a particular process, even if it is get compromised, only that particular process gets compromised and not entire system. So that way cybersecurity works, and functional safety, as explained, SLB, SLC, SLD level first needs to be decided by OEM, and then accordingly a development and requirement comes into picture for that.
Hello, sir. Hello, sir. Hello, sir.
Hello, ma'am.
Hello.
Sir is not there. Yeah. Can you hear me, sir?
Vikas, sir.
Yes, I can hear you.
Sir, what ethical considerations are being done as on today for implementation of AI in automobiles?
Ethical consideration, actually, it's following a standard which has been given for the AI. No, ethical consideration, I am not actually aware of this particular topic. Sorry for that. I need to check for this. Yeah.
Okay, sir.
Sir, you told the safety measures
Hmm.
for a driver. For a driver sleeping mode, you are telling about the safety measures.
Hmm.
What is the time taken? Suppose suppose the driver is sleeping. What is the time the action will take place? All the action you are telling.
Yes. So that's again the explanation which I gave. ASIL-B, ASIL-D level car. Based on that, the timing parameters are also defined. Uh, how it happens, basically how the software development happens in the same scenario. This safety or security development also considered. So at the beginning of a beginning stage of a project or product implementation, there will be requirements from the end user, like I want my car to be like this, like that. uh, Along with that, a safety expert and security expert will be there, and they will see in the lenses of safety and security expert, and come up with the requirements for safety. So now if they decide that our car should be a safety level B, then the time taken to come to that action will be less. And then there are certain protocols which talks about FTTI, fault tolerance interval timeout. So based on that timeout, it takes action. Also, this is about action which has been taken based on any drowsiness symptom. Uh, they also define a requirement. What happens if the particular action doesn't execute? We are expecting it to take a car to the other side of a road by certain time limit, but it doesn't happen. Then what has to be done? That's called as a safety mechanism, safety goal. So there is always, I would say, in simpler term, there is always plan B, which is available for this, and they will always take care of that. So if point A doesn't work, they boil down to point B and they try to execute that. And usually it doesn't happen in the cars that whatever time parameters we are talking about doesn't meet, because we in the cars we use real-time operating system, and real-time operating systems are specifically meant for these operation. They are not like a general purpose OS which gets kind of stuck due to some other operation, or which is busy for something else, and that's why the important stuff is not done. And it's always priority based as well. So the highest priority is given to these tasks which are life threatening or critical. Was that your question, and am I answering your question, or you have any follow up? Please let me know.
Okay, thank you, sir. Thank you.
Is there any other questions from the participants? Magdum sir?
Yes.
Sir, shall we conclude the session, or is there any other questions that we can take?
Conclude, sir. Conclude. No issue.
Yeah, if
Okay.
there are no other questions, I think, yeah, we can conclude this.
Yes.
I
Yes.
hope the session was helpful. You guys could understand or improve something which, or you have learned something new from this time which we have discussed, maybe almost one hour or something. So and I would also like to thank the organizers to giving me an opportunity to present my understanding to the team. Yeah, thank you.
Thank you, sir. So we are here to conclude this session now, and I'm here to present a vote of thanks on the behalf of the organizing team and all the participants. I extend my heartfelt gratitude to Mr. Vikas Chandrasekhar Shreshthi sir for delivering such an enlightening and impactful session on artificial intelligence in electric vehicles under this ATAL FDP. Sir, your vast industry experience and deep technical insight made this session truly enriching. You beautifully explain how AI is transforming electric vehicles, enhancing battery management system, safety, efficiency, and overall driving experience. The way you connected real-world automation applications with emerging AI concepts help us all to gain a clear knowledge about the electric vehicle with AI systems. Once again, thank you, sir, for sparing your valuable time and sharing your expertise with us. We are truly grateful for your contribution to the success of this ATAL FDP. Thank you, sir.
Yeah, thank you. Thanks for inviting. Bye.
Over to you,
Thank you,
Magdum, sir.
Hello. All participants, please stay connected. Okay. Next section will start at sharp 3:30 p.m. Dear participant,